Can you believe that this moving water can light up entire cities? Let's discover how a hydropower plant turns the energy of water into electricity. Hydropower means generating electricity using the energy of moving or falling water, which rotates a turbine and ultimately produces electrical energy. One important concept is head, the useful difference in elevation that provides energy to the water. Generally, greater head and greater water flow mean greater hydropower potential.
A typical hydropower plant includes a reservoir or river intake, water conveyance system, taney, transformer, and a path that returns the water downstream.
The intake controls the water entering the plant, while gates regulate the amount of water moving toward the turbine. The penstock carries water from the higher reservoir toward the turbine. As the water descends, its potential energy is converted into air associated with the flowing water. Inside the turbine, the energy of flowing water is transferred to the runner. The runner rotates, converting hydraulic energy into mechanical energy. The turbine shaft drives the generator. The generator converts the turbine's mechanical rotation into electrical energy. Generate electricity passes through a transformer, where its voltage is efficient transmission over long distances. Then the power travels toward the electrical grid. After transferring energy to the turbine, the water leaves through the draft tube and flows into the tail race, eventually returning to the river. The first major type is the storage or impoundment plant. A dam stores a large quantity of water, although when and how much water is released for generation.
When electricity is required, stored water flows through the intake and penstock, rotates the turbine, drives the generator, and sends electricity to the grid.
The second type is run-of-river hydropower. Instead of relying on a large reservoir, it mainly uses the river's natural flow. With water is diverted through the plant, passes through the turbine, generates electricity, and returns to the river. Because storage is limited, output depends strongly on available river flow. The third type is pumped storage hydropower. It uses two reservoirs at elevations and can both generate electricity and store energy. During high electricity demand, water flows from the upper reservoir to the lower reservoir through the reversible turbine, generating electricity.
When electricity demand is low, the process reverses. Electricity powers the pump, which moves water back uphill into the upper reservoir, storing energy for later.
Hydropower plants also use different turbine designs. Three important examples are Pelton, Francis, and Kaplan turbines. Pelton turbines are commonly suited to high head applications. Francis turbines are widely used for medium head conditions. Kaplan turbines are designed for high flow, relatively low head applications. So remember, storage plants control stored water, run-of-river plants mainly use natural river flow, and pump storage plants store and generate energy. In every case, water drives the turbine drives the generator, and engineering turns water into electricity. The adventure isn't over yet. Subscribe to MindSpark Toons for more amazing stories, history, and learning adventures. See you next time.